When we're solving mixture problems, we're going to have two things with varying concentrations, values, etc., that are being mixed together, and then now we have a total amount. And that total also will have a value, a concentration, a price, etc. So, the first thing you're going to do when you sit down to these problems is you're always going to write, I know this is rather silly, but an equation that's first thing plus the second thing makes the total amount of things. And what you want to make sure you're looking for is what do your two things, groups, quantities, whatever, what do they have in common? Do they have a value, like with coins? Do you have a certain amount of them and a concentration or a percentage of them? Do you have price for both of them? And then our equation ends up looking like our amount times the percent or the value or the price, etc., for the first thing, and then the amount times for the second thing. And then our total is, our total amount times whatever thing it is, the value, the price, the concentration, the percentage, whatever. So you always want to think about this equation. First thing plus the second thing equals the total thing, right? And first thing and second thing and total thing are all going to be multiplied by whatever it is that's our thing we're using, a concentration, a percentage, a price, a value, etc. So let's dive in and see how these work. So Lindsay has $2.05 in dimes and nickels, and there are 7 more dimes than nickels. How many of each coin does she have? So thinking about first thing plus second thing equals my total. I've got some dimes and some nickels, and they add up to 205. So now thinking about what do these have in common? Dimes and nickels are coins. They've got a value, and we need to think about, okay, what is the value of a dime? A dime is 10 cents. Since over here we're working in dollars, we're going to keep that 10 cents as 0.10 so that it's still going to work for dollars. A nickel is 5 cents. So from a dollar, that's 0.05. And then I have some number of nickels. And altogether, this is making $2.05. Everything's in our value. It's measured in dollars now, everything I've got. Now I need to use the second half of this sentence. There are 7 more dimes than nickels. Just as a sidebar, the setup is always the hardest part of these problems. There are different ways to set them up. Every way, not every way, I guess, but different ways can still be correct, even when they look different from the setup. So this is always the hardest part to start with. But I know I have 7 more dimes than nickels, which means like if nickels was X and dimes, is something else, then since there's 7 more dimes, I could make this X plus 7. Side note, you could have said that dimes, was D and nickels was D minus 7 because there are 7 less. It doesn't matter. Either all of these setups will work as long as we keep track of what did we say X is? What does it represent? So in this one, I'm going to say that X is nickels. And if you remember our general strategies for solving word problems, the first thing we're trying to do usually is say, okay, what are we looking for? In this one, we're looking for dimes and nickels. And then we want to make sure, what are we choosing? When you're making a choice, make sure you write down what it was, right? So here I'm going to choose that X is nickels, so I need to keep track of that. All right, so if my X is nickels, my dimes is 7 more. Now I've got a lovely equation, and I can use my excellent solving skills to distribute and simplify this problem, solve for X. Then I will know how many nickels I have. So I'm going to distribute. I'm going to combine like terms. I've got these X's and these X's that together will make 0.15 X's. So I have 0.7. I'm going to subtract that 0.7 from both sides. And then I'm going to divide to get X all by itself on one side. And when I do that, I'm going to find out that I had 9 nickels. How fantastic. The problem doesn't say what's X equal, though, right? It says how many of each coin does she have. So now I know that nickels, there were 9 of them. And for dimes, it's 7 more. So I'm just going to go 9 plus 7 is 16. And that's my final answer. We're going to try a different type. Here we've got a concert where we had $1,506 in ticket sales. And there were $6 student tickets and $9 adult tickets. So I'm going to start with just that. Student tickets plus adult tickets was $1,506, but actually this is in dollars. So I don't want number of student tickets. I want number of dollars made from student tickets. So each one was $6. So 6 times the number of student tickets and 9 times the number of adult tickets. Those are my prices or my values for these ones, right? That's what we have in common is dollars. All right, now we need to use that next sentence. The number of adult tickets sold was 5 less than 3 times the number of student tickets sold. Let's break that down. Adult tickets was 5 less than. Be careful, that always goes after, right? That's the -5. It's not 5 minus. It's taking away 5 from whatever we have next. 5 less than 3 times the number of student tickets. Down here, I was using S for student tickets, so I'll keep doing that. You don't have to. It could have been X. It could have been anything. 3 times, multiplying 3 times the number of student tickets sold. All right. We took that word problem sentence and we made it into a mathematical equation. The number of adult tickets was 5 less than 3 times the number of student tickets. Fantastic. So here I have an equation in 2 variables, students and adults. I now know, though, that A, my number of adult tickets, is equal to this guy, 3S minus 5. So I'm going to replace the A in this problem with what I know it is also equal to. It's also equal to 3 times S minus 5. And everything else is going to stay the same. All right, let's distribute, let's solve. I've been writing dollar signs to keep in mind that everything's dollars. I really do not have to, but if it's helpful for you, you can too. 1506. All right, that means I have these guys together. 33 times S minus $45. I'm going to add these $45 to both sides. Now I've got 33S equals 1551. Still in dollars, everything. And when I divide by 33, what am I going to get? We're going to end up with S equals 47. So that means they sold 47 student tickets. Now the problem, though, says how many of each kind. So I also need to find my adult tickets. To do that, look, I already have an equation I made. How fantastic. So I'm going to go 47 times 3 minus 5 to see that I got 136 adult tickets. If I put these numbers back into this equation, I should still get 1506. And I can do that to double check my answer. All right, Monica paid $8.36 for stamps. That's my total. She bought 41-cent stamps and 2-cent stamps. Sorry, I'm not reading this problem. Let me read it. The number of 41-cent stamps was 4 more than twice the number of 2-cent stamps. How many of each kind of stamps did she buy? So I have 41-cent stamps plus 2-cent stamps. And then altogether, that was $8.36. So I'm going to change this, 41-cent stamps. I'm going to use the value of those stamps, which is 0.41 times some number that I bought. And the value of those 2-cent stamps, 0.02 times whatever number we bought. And that makes $8.36. Side note, I could be using dollars the whole way, just like I did in the last problem. You don't have to, but if that helps for you. All right, The number of 41-cent stamps was, let's just really quick. Let's say that X is 41-cent stamps and Y is 2-cent stamps, okay? So the number of 41-cent stamps is 4 more plus 4 than twice the number of 2-cent stamps. All right. So I can just take this lovely thing. What did I say? X was for 41-cent stamps and Y was for 2-cent stamps. So I'm going to take this and plug it in instead of X because I know that X is equal to that whole lovely thing. Okay, we're going to distribute, we're going to solve, we're going to find out how many stamps we bought. Oop. Gotta lose that decimal point. Boop. We're going to combine like terms. We're going to subtract 164 on both sides. We are going to have a number. And now we need to divide by 0.84 to get Y all by itself. And when we do that, oh my gosh, how nice. We get 8. So that was Y. That was my 2-cent stamps. Okay, we bought 8 2-cent stamps. How many 41-cent stamps did we buy? We can use this lovely equation we wrote to figure it out. 2 times 8 plus 4. We bought 20 41-cent stamps. And if I want to double check that that actually works, I can plug those numbers back into my very first equation and make sure that they make $8.36. Rolling on. Henning is mixing raisins and nuts to make 10 pounds of trail mix. Raisins plus nuts equals 10 pounds of trail mix. Raisins cost $2 a pound, and nuts cost $6 a pound. And Henning wants his trail mix to be $5.20 a pound. I didn't really leave myself room on the left where I would have liked to write it, so I'm going to write it on the right. But it doesn't actually matter, right? 2 times 3 is the same as 3 times 2. It's just an aesthetic thing. So Henning wants his cost for the trail mix to be $5.20 a pound, and he needs to know, okay, how many pounds of raisins and how many pounds of nuts? Sometimes these problems tell us, oh, this many more raisins than nuts. This one didn't do any of that. Oh, what are we going to do? We have 2 unknowns, raisins and nuts. The one thing we do know, though, is that we're making 10 pounds of trail mix. So we need these 2 numbers, these R and N, to add up to 10. So I am going to pick, it doesn't matter, R or N, and get it all by itself on one side. How about R? So R is 10 pounds minus however many pounds of nuts we had. We are going to put that in instead of R. Okay, that guy's going in right here. So now we've got $2 times 10 minus N plus $6 times just plain old N. And that makes, I'm going to switch it because I like it, $5.20 times my 10 pounds, right? Double checking. This plus this makes this. That's how we do our totals every time. We want to make sure that our amounts add up to our total amount. Okay, let's distribute and solve, huh? 20 minus 2n plus 6n equals 52. Those n's are going to combine to be 4n is 52. We're going to minus 20 on both sides so that we have 4n equals 32. We're going to divide by 4, and we need 8 pounds of nuts. We need to know how many raisins, though, but so easy this time because we know they add up to 10. 10 minus 8, 2 pounds of raisins. So Marco has $8,000 to save for his daughter's college education. He's going to divide it between two accounts. One pays 3.2 interest per year and another pays 8 interest per year. Sidebar, put all your money in the 8% interest. What? Why would you do, whatever. Okay. How much should go in each account if he wants the interest on the total to be 6.5%? Okay, so we've got 3.2% times some amount plus 8% times some amount, which is going to end up being 6.5% times our total amount. We know actually our total amount is 8,000, so I can put that one in. Okay. These guys I don't know, but I know they add up to 8,000. Using the same trick from the last slide, right, where they added up to 10, I can just pick one to be X. It doesn't matter which one. And the other one is 8,000 minus X. That way, when you take this and this together, it'll add up to 8,000. All right, time for some multiplying. I'm going to switch these percents actually to decimals to make my life easier. So I don't have to divide everything by 100 at the end. So I have 0.032x plus 640 minus 0.08x equals, and then let's find out what 6.5% of 8,000 is. It's 520. All right, that was a 6. Combining like terms, these guys together, we have got something negative 0.048x. It's okay that that guy's negative because look, this guy is going to be negative too. All right, so now we've got, this is negative 120. We will divide on both sides by negative, don't forget your negative, Lindsay, 0.048. And what will we get? X equals $2,500. So the 3.2% account, right? That's where we had X. The 3.2% account, is going to get $2,500. And the 8% account is going to get whatever's left, right? So that's $5,500. I know these are kind of a lot to set up. They're not too bad to solve usually. The hardest part is the setup. We're going to do one more. Steph needs 50 ounces of a 20% salt solution. She has a 35% one and a 10% one. How much should she mix? Reminder, she wants 20% of 50 ounces. That's what we actually wanted. Now, just really quick, whenever you're mixing between two values, right? Here's my 10% and here's my 35%. When I mix these together, I have to get something in between those. I can't end up with 45% solution because I wasn't adding, I just don't have enough salt in the solution for it, right? Anytime that we're like mixing things together, we have to be in between for the average. So since this was 20%, which is a little closer to 10 than it is to 35, we have to have more of the 10% solution than we do of the 35% solution. Like, just because if it was smack dab in the middle, at 22.5%, we would have half and half, right? And if it was farther on this side, then we have more of the 35% solution. If it was more on this side, we have more of the 10% solution. Just kind of a general rule. Anyway, sorry, we're coming back. These two things add up to 50. We're going to make up one to be X and the other one's going to be 50 minus X. Okay? Multiplying, distributing, solving. Ooh, what is 20% of 50? 10. It's 10. All right, combining like terms, I have 0.25x plus 5 gives me 10. I'm going to subtract 5 on both sides. And I'm going to divide by 0.25, which tells me how many, what we had, ounces of the solution, of which one? The 35% solution I need. So the 35% solution I needed 20 ounces of. And since it's 50 altogether, 50 minus 20 tells me I need 30 ounces of the 10% solution. Does that track? Yes. We said at the beginning it should have been more of the 10% solution. So excellent. One more thing to look out for. We have just done ones where you have your total and you don't know how much of each. Sometimes, though, you're going to have ones, let's use those exact same numbers, 35% solution and a 10% solution, and altogether we have a 20% solution. Sometimes they're going to tell you, oh, we used 8 ounces of this and some amount of this to make a 20% solution. And what we don't know, is how much we added or how much we have total. When you have these problems, you're going to do the same thing we did before, and you're just going to say, well, it's X. It's some number I don't know. And then you're going to use that skill that this plus this makes this, right? To make this 8 plus X. When you solve this, and since I just made up these numbers, we're not going to have like a nice number. But when you solve this, the only thing you have to be careful of is having an X on both sides. And you know how to solve those. It'll be fine, but start with getting your X's on the same side. So since I had, it didn't matter. I decided to move my 0.10x. You could have moved your 0.20x. Does not matter at all. That was just my first step that I did. Then we're going to get that X all by itself. And then, is that right? No, that's a 2. Don't do math without thinking, guys. It's important to think. 0.10x, right? And then you solve for X, you get, a lovely answer, hopefully. But make sure at the end, you're like, well, what was X though, right? So in this one, X was how much of my 10% solution, which means altogether I had 20 ounces, right, of this solution. That's just helpful setup for the problems when you don't know how much you added or how much you have total. Good luck.